Okay, BYP working on the 86602B RF section after getting the 8660 mainframe finished. Boy, was that a job. But came across a serious problem on the A4 card. Actually, problem with the manual. A4 card is the center slot here. A4 detector amp, and there's a chance to seriously wreck this unit by referring to the online manual. I think it came from Bama, and there's a page missing. But this is a card that ultimately drives the front panel meter, and that's what gives the indication of the level. The page is missing, leaves out the three tantalum capacitors on this board. There are two 6.8 at 35s. See how I'm writing the values? As I cut the old capacitor out, I write the value on the board in ink. And that's after checking the plus indications to make sure they're correct. But there's a capacitor hiding back here under Q1, and it is critical. And if you notice, if I can get in close enough, see the faint 1U? We'll see the dot in front of it. Don't make the mistake of thinking that's a 1 microfarad, that's a tenth. On the schematic for A4 detector amplifier, 86602 over here, U1, C5, 0.1 microfarad, low pass filter. Don't get that value wrong, because that is what drives the meter, and that's what much of the alignment is based on. That's a feedback loop around that op amp. You do not want the wrong part. You do not want a part out of tolerance. Since the parts list is not here, I can't determine the percentage of tolerance. It may be plus 10 minus 50. But what I'm going to do is cheat. I have 0.1 at 35 tantalums, but they are 35 volt 0.1 10%, which is typical for the mainframe unit and all the 0.1s there. But I'm going to replace that with, since I understand capacitor types, with a pulse forming capacitor, polypropylene dielectric, high stability, 0.1 at 1%. And that little change might just be good for more accuracy in the readout of the RF level meter. And that capacitor has been measured at 99.86 nanofarad, which is so close to 0.1 we can't even think about it. Observations on this unit: don't even think. Don't even try to use mental energy to bend these rigid lines. You bend them once, you're done. Those are hard lines to the microwave assemblies. Don't mess with them. Don't open them. There's a 6.8, probably at 35 down inside. There's got to be replaced. That may not be in the manual, or may be easy to miss. These microwave amplifier detector assemblies have heat sink compound between them and this aluminum plate. I would not take those off to renew that heat sink grease for the risk of mechanical damage, electrostatic damage, breaking, cracking, compromising one of those connectors. And that metal plate doesn't offer a great deal of heat sinking anyway. Nice thought, but not real practical. So, an example of how these eject levers work. Putting the board back in that I just took out, it's necessary to lift both these at the same time, which is difficult to do with this little board. So I reach in and cross my fingers like that, and watch what happens down here. It draws the card up smoothly and evenly and pops it out. Putting it back in is a problem. In the mainframe unit, we can't see the landing of this edge card in the sockets. And it's going to tend to drop in who knows where. It might drop in like that, off center. We don't dare push down. What we do is grab it up here and wiggle and jiggle it around until we feel it drop in slightly. If you see the numbering on that switch up there, there's where it first touches, and there it's dropped in a little bit. And what that's doing is locating that, not here on this edge, but down inside. Push these down, wiggle, jiggle that, wiggle it that way, jiggle it a little bit, and then press steadily and evenly. It doesn't want to go there. So I need to take that board back out. It has to come out anyway. And I'll feel along this edge, and there's a square edge. So I need to scrape off the square board material there and make that edge rounded. So let's see. There are those boards. There are the boards back here. There's a switch here. This front cover needs to be taken apart, and that switch deoxidized with brasso. And make sure the center pin and the end connector isn't corroded. The segments aren't sprung apart. That one looks pretty much like new. But a bad connection there will just drive this thing crazy, because we're talking about 0.03 microvolts. Okay, this thing is not going to tolerate a poor connection on that end connector. Worst comes to worst, replace it, because the voltage level agreeing with the dial, agreeing with the meter, requires, according to the manual, a 50 ohm load. If the load isn't 50 ohm, then the output won't be right, won't match the reading. If it's intermittent here, that'll cause a lot of noise, also mess up the output. So high precision microwave assembly, be very careful. Down here in the bottom is the magic in this assembly, and that's the attenuator. Do not disassemble means do not disassemble, means don't disassemble it. Built like a tank. Taking it apart is probably going to destroy it. Not from taking it apart, but for letting moist air inside, because that assembly should be filled with inert gas. Looks like there are little tuning screws in the side there. The purpose of the inert gas is to keep moisture out and oxygen out, both which will oxidize and corrode the internals. And at really high frequencies, mechanical dimensions and surface finish and surface oxides become really important, because as frequency gets up into a few hundred megahertz and above, the energy travels on the surface of a conductor. That bent hard line there used to be shiny. It's covered with silver oxide now. If current were try to flow on the surface of that, it would try to flow through the oxide layer. Wouldn't find a very good path. So don't take that unit apart unless there's absolutely no reason that you can get around it. And if you do, clean conditions, and probably have to be prepared to charge it with nitrogen and reseal it. So that's kind of a guess there. I don't know what's inside there, but I sure know I don't want to mess with it. So KBYP did it.